Okay, and I've got to remember, I'm trying to record these days because people have been out for large stints because of COVID or injuries or whatever. So I'm trying to record these. I missed the beginning of today, but today's semester 2. We are doing trig inverses, so that's undoing trig. And part of the way to start that is to know what the regular things look like.
What's the second one? Arc code? Arc sign?
Okay, so I will make this a little bit bigger. Just a little bit. Is that any better?
You're a little bit slow.
Yeah.
Bigger still? All right, I'll try. Oh. So you guys should be able to do the graphs of sine, cosine, and tangent. So put those in there. They let the sines start high, low, or in the middle? In the middle. Oh, interesting. Okay, where did it go? Sorry, guys, I don't understand what's going on, but. All right, awesome. Okay, so in the middle, and Fernando, does it go up from the middle or down normally? Up from the middle.
Unless it's negative though.
Unless it's negative. So normally. So I fixed myself. I was like, wait, normal. So William, what's the period of sine?
Oh, 2 pi.
2 pi. And little tick marks. We can put the tick marks anywhere. Nick, what's the lowest that the sine goes in the highest? -1 to 1. So, Peter, what's the domain for sine? What are all the x values that I could put in? All the numbers that could ever be numbers. Serene, what's the range of sine? What comes out? Including or not? Does it hit -1? Does it hit +1? Yes. Sarah says including. You agree? All right, good. She's right. Okay, Emilio, cosine. The graph of cosine.
Starts at the top.
Starts at the top normally, unless it's negative. William's gonna throw that in there if I don't say something. So it starts at the top. Donovan, what's the period of cosine? 2 pi. Mara, what are all the numbers that go into cosine? What's the domain? All the numbers. Yuan, what's the range? What numbers come out of cosine? Did I get the name wrong? Yuan?
Got a question.
Oh.
What's all real numbers?
What does all real numbers mean?
Negative infinity.
So that funny looking R with 2 lines on it means all real numbers, and that's negative infinity. It's any number can go in. Include. Okay, -1 to 1 included. Monica, what does tangent look like?
That goes like that.
So,
Or the asymptotes have pies.
are the asymptotes at, okay, so first of all, it does have asymptotes.
No,
Good.
it's not that wait.
Is it at pies or pies over 2?
Pi over 2.
Oh, that's close.
Serene says asymptotes at all the over 2s. And I see a lot of people have this drawn right. And it repeats itself a whole lot of times. Okay. Domain stinks. I don't want to write that one down. Sarah says all real numbers for range. Okay, does anybody remember how to say
These are like all real numbers except for
All numbers.
pi 2. I think, or something like that.
yeah,
Is it pi over 2 and
Pi
then
over
pi?
two
Nice, bro.
plus
And
n.
nice.
What's N?
Get into it.
What's the variable? So
It's like it.
it's integers.
It's an integer. It's some whole number. It's positive or negative, 3, 5, 8, whatever. So it's basically all the odd numbers of halves of pi. Cool? Lynn, you're gonna keep me honest on the details. It's gonna kill me. But that's a good thing. I'll just be kind. Okay, so we have half the chart filled in. Is this familiar from last semester?
Yeah.
Okay. All right. So we were able to say things like sine of pi over 6. What is sine of pi over 6?
30 degrees. 30 degrees.
Pi over 6, pi over 3, across from pi over 3 is root 3, 1, 2. What is sine of pi over 6?
It's a 30.
Root 3 over 2.
Sine is opposite over hypotenuse. So opposite of pi over 6 is 1.
Hypotenuse over.
How do I do
Is-
it?
Oh, the sun.
Oh,
Sine-
it's cosecant.
Oh, sine.
Oh my goodness.
Cosecant.
Is it?
Sine of pi over 6 is 1 over 2. The reciprocal, the upside down of sine, well, just 1 over sine of something is cosecant.
That's what I was thinking.
Yeah, some of you are like saying similar things, but yeah, all right. Sine of pi over 6 is 1/2. We now need to be able to figure out things to say undo sine. To say sine inverse of 1/2. This is asking what angle makes sine equal 1/2.
Pi over 6.
Now that we've just done that, it's pi over 6. So that second, in the chart, every other row that we were doing had these guys. Arc sine or sine inverse. Please be careful, both of these are the same thing. Arc means undo the trig function. And this to the -1, unfortunately, x to the -1 means x over 1. But from algebra 2, do you guys remember that notation? F and that to the -1 was called inverse. So here's some notation. I can say sine inverse or I can say arc sine. I can say cosine inverse or arc cosine. And the SATs and ACTs, those of you that have taken it, do they use both notations? Genevieve, it's been a while for you, but do they use both?
I think so.
I think they do. All right. So, to do inverse, just as an example, what's the inverse of x squared? How do you undo squared? Square root. And square root looks like this. How come it doesn't have the bottom of the u? Fernanda, what are you saying?
I think because it doesn't exist. I don't know.
What makes a function a function? Like, is
Can't be
this
negative.
Oh, they can't have two.
vertical line text? So this U shape passes the vertical line test. It doesn't cross that line more than once. If I put the bottom of the U on it, it's going to cross twice, and that's a problem. Okay, that's why we don't have the bottom. All right, so I need to do this with sine. Sorry, this looks gross. Here's my sine function. And finding an inverse, the x and the y trade, and it's gonna make, when I trade those x's and y's, it makes this curve. Does that pass the vertical line test? It has to not hit more than once. It hits an infinite number of times, it's a problem. Okay, so I need to choose just a small slice. Alvin, I'm gonna take my little viewfinder and I need to get a full bottom to top of my trig function. So where should I put my little window that it just gets -1 to 1 for the cosine function?
Can you repeat that? Sorry.
It's a confusing question, so I'm gonna just answer it. That little window there, do I have all the y values of cosine from the bottom to the top? -1 to 1? Yes?
Yes.
Okay. What angle makes that one at the very bottom? 90 degrees, not positive though. Negative pi over 2, and this one is positive pi over 2. What's the problem? William, do you have a question?
I don't understand like the pi over 2 thing.
Okay,
Because we know on like the unit circle, like 90 degrees is pi over 2.
Oh yeah.
Half of it.
Oh,
Half of
okay.
the pi.
yeah, we're trying to make you only speak in radians now. Sorry.
Yeah.
So I'm gonna pull this piece out, and this now, does it pass the vertical line test if it's traded? It does, by the way. So can you guys copy this stuff in for the picture of arc sine? Oh, and I didn't change the graph. Too thick. So you should be adding these to your chart. And the piece of the graph, put the scale on it. The x values should go from -1 to 1. And the y value should go from negative pi over 2 to positive pi over 2. So sine inverse is that graph. So it's weird, but that's sine inverse, that's all it is, that little swoop. And copy down the domain and range that's up there, the stuff that goes into sine inverse, -1 to 1, the stuff that comes out, -pi/2 to +pi/2. So again, inverse, the way this is read. So Joey, what angle makes sine -1? There's an infinite number of answers, but William, yes, the -1, what angle?
Oh, that's gonna be,
Okay. So William was saying, oh, wait, we want the y value, so we want the guy that's down here.
270 degrees.
So 270 degrees, 3 pi/2, and your calculator is never gonna give you that answer. Your calculator is gonna give you this one. And, okay, so guys, it's kind of important that you understand the restrictions now. How many of you drive? Okay, so driving, if you were to drive from here to Silver Spring, would you go around the Beltway and go through Virginia, over the drawbridge and back up? No, like that'd be like horrible. Part of that bit of the Beltway is called the Mixing Bowl. I used to live there. That sucked. So no, you would go the short way around. So in these things, we're gonna do the angle. We're gonna take it on the short route. So William's right that whereas sine -1, 3 pi/2, we want to go the short way and make it that -1. So there's
this can be -90.
-90. Yep. Okay. Now we need to do the same thing with cosine. Here's cosine. I need to put a little viewfinder on there so I can get the y values high to low. So Serene, where should I put my little viewfinder so that I get the high to the low? Let's see. So Serene, the rectangle that I drew up here, does that cover -1 to 1? Does it have all the values on it? No, so I need to make it a little wider? Okay. How about that? No? Well, is that in the right place? Like, is that, would I restrict this from -2 pi to -pi? Does that make sense? Like, is there a more convenient place? 0 to pi? Yuan says 0 to pi?
No,
No, why not?
it's gotta be -pi/2 to pi/2.
Okay, if I go -pi/2 to pi/2, looking at the little,
It would fail the vertical line.
so do I get all the y values -1 to 1? No, I get 0 to 1 twice. So I kind of like this spot. Okay. These are weird. I mean that in a good way. All right. So can you guys copy this one down? How about that? You see it? Okay, so can you guys copy this in for arc cosine? That arc cosine graph looks like this. I meant to make it thicker. Put a scale on it. Inputs -1 to +1, outputs 0 to pi. Inclusive, square brackets around those. Careful, this is not right. Starts at 0 to pi and -1 to 1. Doesn't go below. Can I see your cosine inverse? Okay. Okay, this guy. Then we'll go below. One. It doesn't go below the x-axis. Sine inverse does, cosine inverse doesn't. So, looking, some of you have this going below the x-axis, and it doesn't.
It doesn't go below it.
Does not go below it. It starts at 0, a y value of 0. So, what angle makes cosine 0?
One. Oh, to make it 0.
Did one person say the right answer? Cosine of 0, not cosine inverse, but cosine of 0 is 1. I want to know cosine of what equals 0.
1.
Okay, there it is. More of you are getting it right now. If you need to do, like, solving these in the beginning, this might be easier for you. If I'm asking cosine inverse 1/2, that's asking cosine of what angle equals 1/2. There's a whole bunch of answers. However, I want the one that's in this graph. So that would be from quadrant 1. Which the one place that that's going to happen is pi over 3. Yeah. Okay. So we have tan inverse to get through now. How do you guys do it? Serene, do you need time? You still copying? Pi over 3. Pourquoi? Because
That's French, by the way.
je sais. Je ne peux pas français. Bonjour, Paquette. Hello, Fred. Je suis un pamplemousse. Hi, and I'm black. And my Spanish is just as good. El taxista tiene 2 servicios, debería pagar 2 veces. The taxi driver has 2 noses, perhaps I ought to pay him twice. Completely useless. But I say it well.
Yeah, you did.
Okay, y pi over 3. My cosine curve. I need to restrict it to the little viewfinder you guys had agreed on, which was here to here. The one place that I hit that pi over 2 is there. In quadrant 1, where is cosine 1/2? All right. Across from pi over 3 is root 3. 1, 2. Where is this adjacent and this the hypotenuse?
Well, that's a 30, 60, 90 triangle.
It sure is.
Yup.
Pi over 6, pi over 3. We're going to get you to radians eventually. So where is this 1/2? Pi over
Side third.
sine 30 is 1/2, but cosine of 60 is
Oh.
1/2. What you said wasn't wrong, but it wasn't what we asked.
Oh, I don't remember what you asked. You just said 1/2 like this.
Okay, all right. This one's the easy one. Tangent inverse. Where does it look like we should take the obvious slice? What do you think? What do you think? Where should we take the slice to get one complete wiggle of tangent?
Let's take a negative power to
Where? So she says, this one is looking mighty good. Negative pi over 2 to pi over 2. Does it? Yes.
So this one does cross.
This one, okay, this is the function itself. I need to do the inverse. Inverse is, if I erased all the rest of this and flipped it over, I gotta flip it over y equals x. It looks really, really different.
I just,
Do you guys know what it looks like?
I have a feeling. Yeah, it looks. I remember doing I don't know which one it is called.
I'm writing an eraser. Awesome. Go me.
Not really good.
It's gonna look like this, which is really, really, really different than the original function. So here you go.
Isn't there an name for a bar like this? I recall doing like this in algebra 2 last year.
This looks like a cubic inverse, but it's not. It's arctans. And these guys are asymptotes. All right, the big thing I want to make sure that you get correct on your paper. Domain, what things go in? Negative infinity to infinity. Domains and ranges traded. What things come out? Round brackets. Good. The range, I don't actually hit negative pi over 2. I don't actually hit positive pi over 2. So these guys are round brackets. So can you draw that one in there? It's hard to draw this
I
one.
think that's just negative.
The wiggles go the other way. So it's like, it's tired and then it warms up and then it goes fast and then it's like, I'm tired again.
It's so sad.
Sorry, it starts at negative pi over 2, so I didn't draw it well to your scale. I apologize. To positive pi over 2.
Look how beautiful my
Gorgeous, love it. Oh, your arctan's a little bit sad, so.
I gotta fix my cosine.
Okay, so tangent, it takes a minute to warm up, but then it starts running faster, and then it gets tired out, and then it tapers off. Okay. So, does everybody have, put the phones away, people. Just a warning, have the phone jailed ready, hang on the wall. It's like, if you're on your phone too much, like some of y'all need a divorce, you're like on that phone all the time, it's just disgusting. If I gotta warn you too many times, it's going in the phone jail.
Just Pascal, how long will mindful sleep?
How long does your phone stay in jail depends on how big a violator you are. Depends on the seriousness of the crime, how long it's in jail. In general, I'll give it back to you at the end of class. But if you're a jerk about it, I don't know. Okay. So, guys see the difference? If it's sine, just sine, you put in an angle and you get out a ratio. So sine of pi over 2, that one is up there. Sine's the x value or the y value, Jayla? Which one is it? Is sine the x value of the coordinate on the unit circle or the y value? The y value. So Ismael, what's sine of pi over 2? 1. Okay, Maya, this one is sine inverse of a half. So you put in the ratio and then you get the angle out. First of all, the angle is going to come from one of these two quadrants. Is it going to come from quadrant 1 or quadrant 4? Where is sine positive? Quadrant 1. Okay, yeah. So Nick, where is sine a half?
9 degrees. No. 30 degrees.
This is pi over 6.
45.
30 degrees, pi over 6.
Just do it.
But what it have?
Okay?
I thought sine.
William, I'm determined to get you to like radians. Okay. So whenever you draw this triangle, I always say across from pi over 3 is root 3. The longer side is 2, the smaller side is 1.
Yeah, the long one is root 3. The bottom, the short one is 1, and then the hypotenuse. So
Yes,
Yep.
I agree. And so that you don't have to do degrees across from pi over 3 is root 3. They got a little commonality there, yeah? Yeah? You don't seem to like it. I want you to love
I gotta
radians.
get used to it.
You
It's very
do.
uncomfortable.
Rocking the shoe. So looking at this, where is opposite 1? Well, here's the 1. It is opposite for pi over 6. So sine inverse of a half is pi over 6. Okay. So this is just what the graphs look like, nice and pretty with the correct things on them. And these guys are asymptotes. And capital A, I didn't talk about capital letters yet. That means restrict the function. All right, we're gonna try something. This is kind of what your chart should look like, and this is what I'm gonna look to see that you have completed tomorrow. Like it should be in your notes in a neat fashion where you can like reference stuff. Okay. What functions are positive in quadrant 1? All of them.
Oh, I gotta remember.
Of the big functions,
Sine.
sine, cosine, tangent, which one?
Sine.
Sine is positive here, okay?
Tangent.
Next is tangent, and last is
Sine is positive
I'm a
here.
genius.
homogeneous.
You're all geniuses.
Oh,
Okay. But where we would get negative ratios from, your calculator, you don't want to ask the calculator and say cosine, where is cosine negative 1/2? And have it one day say, 5 pi over 3. Oh, but wait, it's Wednesday, so I'm gonna make it 2 pi over 3. And then maybe some other day, like you don't want it giving you different answers. One of those was wrong. Capital letter, it's not the real reason, but I'm gonna say, what's the calculator's answer? The one and only answer. Cosine negative angles come from here. Sine and tangent negative angles. Negative ratios spit out angles from there. Okay, I realize this doesn't make any sense yet. So Isara, if I asked you what angle would the calculator spit out if you said, where is sine negative 1/2? Okay, so it would have to be from the third to the fourth quadrant. And William, radians, where is sign positive 1/2?
Sign positive. I don't get the posts.
Across from pi over 3 is root 3. What angle makes sine 1/2? Sine is opposite over hypotenuse, so 1 is opposite which angle?
Pi over 6.
Pi over 6. Okay, so the angle that I want is some kind of reference angle of pi over 6 in the third quadrant or the fourth quadrant. Down here. All right, guys. I hope most of you have that chart in there.